Hello, everyone. Welcome to Professor Mad. Today, we're going to explore an exciting analogy that will help us understand a fundamental concept in mathematics, functions. So, let's dive in. Think about a washing machine. When we load it with dirty clothes and run the process, what do we get? Clean clothes. This transformation from dirty to clean represents the functionality of a washing machine. Here, the dirty clothes are the input of the washing machine. The output is clean clothes. In fact, we can represent this functionality of a washing machine using a simple equation. This equation shows that the output, which is the clean clothes, is obtained by subtracting the dirt from the input, which is the dirty clothes. This is a simple function that represents what happens to the inputs in a washing machine. Just like washing machines, there are many other machines around us that take various inputs, process them, and give outputs according to their specific functionalities. We can write down the functions for all those. Simply, a function represents how the inputs are treated to give certain output. A function can have more than one input. For example, think about a coffee maker. We put water, coffee powder, sugar, and milk into the machine, and it gives us delicious coffee. This machine mixes and boils the inputs, so we can write the function of a coffee maker like this. There are several inputs to this function, but always keep in mind, one function always represents a single output. When a system has multiple outputs, we represent each output with a separate function to demonstrate how they are created by changing the inputs. Each function describes the relationship between the inputs and one specific output. Let's summarize what we have learned so far. Now let's bring these concepts into the realm of mathematics. In mathematics, we deal with numbers, and just like machines, we can create functional blocks that take input numbers, process them, and give outputs. For example, let's say we need a functional box that multiplies any input number by 2. We can show the output of this system like this. Let's talk about another example. Imagine you need to convert temperature from Celsius to Fahrenheit. This is our mathematical machine. When we give it a temperature in Celsius, it gives it in Fahrenheit. The output of this machine can be written as a function, like this. In mathematics, we normally use the letter X to represent inputs and letter Y to represent output. Sometimes we name the functions using different notations. This is called the basic notation for a function. When we encounter the notation fx, it signifies the name of the function, which is f, and the input to that function represented as x. So, f of x is how we read it. This name f and variable ax are subject to change based on the context. For example, we might use gr, hv, or any other letters to represent different functions with different inputs.
Thank you for watching us. Like and subscribe Professor Mad for more interesting videos.